This is like distribution, sort of, because when we raise a power to a power, we multiply. And when we have two bases, we multiply this external exponent times each of the internal exponents. So I'm going to multiply here, I'm going to multiply here. So this becomes b to the -4 times 4/3 times c to the 1/3 times 4/3. When I have a whole number times a fraction, if this denominator will divide into the whole number, I can reduce it, but since it doesn't, we just multiply the numerator times the whole number. So this is b to the -16/3 times c, and here multiply to the 4/9. And since I cannot have a negative exponent, I have to throw it in the basement, so this becomes c to the 4/9 over b to the 16/3. Okay, here I have, oh, that's a 5. So I'm going to distribute that to these two exponents. So I get z to the 3/4 times -5 times y to the 1/5 times -5. 4 won't go into 5 at all, so I'm just multiplying this 3 and -5. So I get z to the -15/4 times y. Here I have 5 and 5, so they'll cancel each other out, leaving me with a -1. So -1 times 1 is just -1. These are both negative, so I have to throw both of them in the basement. And since I have an exponent of 1, I can just leave it off. Okay, so we're distributing a to the 1/3 times -5/3. Hey, just for fun, let's make that negative. And then I get b to the -3rd times -5/3. Here nothing will cancel, so I'm just going to multiply, and I get a to the -5/9. Here my 3's will cancel, and then I have a negative times a negative, so that's a positive b to the 5th. And since a is negative, we're going to throw him in the basement. So I get b to the 5th over a to the 5/9.